Well, this will be page 3 for Geography, Chapter 2. We'll get this chapter finished up. We start out with a drainage basin. This is an area drained by a major river and all of its tributaries. And in this picture, we can see the Mississippi River drainage basin, which is huge. You go from the Rocky Mountains, the Continental Divide that sends everything east of the divide into the Mississippi River, and then you've got the Appalachian Continental Divide and everything west of that coming into the Mississippi River. In this picture you can see a lot of space is filled up with rivers. I remember the first time my wife's sister lives in Lincoln, Nebraska, and we go back occasionally. And the first time we went to Winter Quarters, an LDS church historical site, right next to it is the Missouri River. And so I said, well, let's cross this bridge into Iowa, then we can say we've crossed the Missouri and gone into the state of Iowa. So we crossed, came back, but first time I saw the Missouri, it's a huge river. And then a few years later, we went out to Nauvoo and actually saw the Mississippi, and it's like standing next to a lake. It is so big. But where we saw the Mississippi would be up here, probably right in that area there, and there's a lot of the river left and a lot of major rivers that come into that. The Missouri, the Red, there's the North and South Platte rivers, the Ohio, the Arkansas, there's just a lot of rivers that flow into it. So I'm not sure what this purple area is, but again, that's a huge drainage basin. Water table, the level at which the rock is saturated. We already talked about the water table, or the groundwater, and it is all part of the hydrologic cycle. It can come up to the surface through pumping for use in farms, and also transpiration. The plants and trees and the vegetation can get the moisture out of the ground. Relief, I think we may have even talked about this in chapter 1. The difference in elevation of a landform from its lowest to its highest point. And you can see on these two maps through the use of color and shading that you can see here's the top of the mountain, here's the canyon, here's the hills or whatever. So easily able to identify those physical features. So through the color and shading, we're able to see the relief of that area. Topography is the combined characteristics of landforms and their distribution in the region. So as we look at this map and this one, these are topographical maps. We can see on this one, the other one has it as well. This is a little more clearly defined. You've got these elevation markers, and they show us through the contour lines all of the same elevation as they go around these mountains and hills. And again, there's some color, there is a little bit of shading, but mostly these contour lines help us to see the topography of an area because we're looking straight down on it. Tectonic plates are enormous moving pieces that form the Earth's crust. They're called plates because they are very large and flat. I think the Earth's crust averages, don't remember where I heard this, somewhere between 5 and 30 miles in thickness. So that's, again, very big, but flat is why they're called plates. So tectonic plates, plate tectonics is another way to say that. Seismograph, a device that measures the size of a wave created by an earthquake. This picture is taken from the University of Utah, and you can see the seismograph machine. So they have sensors out in different areas, and it will pick up those vibrations in those different areas when they have even small shakes that can happen. So the epicenter is the point on the Earth's surface that corresponds to the location in the Earth when or where an earthquake begins. So here's the country of China. We've got the epicenter right here, So that's the point above the Earth where that point or that epicenter is or was. So then we can take this and we can make a cross section of that ground. Okay, so this one here, we're looking at it this way. Then we turn it on its side. We now can make a cross section, and we can see the epicenter down in the earth and the fault line. And so those waves from that earthquake will radiate out. They can go through land. They diminish as they go farther away. They can go through water, and that's what causes tsunamis. We'll talk about that at the end. Okay, the Richter scale, a measurement of the amount of energy or strength of an earthquake. It goes from 0 to 10, 10 being absolute destruction, but a 9 and over is near total destruction. You can see 0 through 5.9 are just white, and then when you start with 6, they're in the red. Now, one thing I heard about these, I hope this is correct, is that when you go from a 1 to a 2, it's 10 times stronger. A 3 is 10 times stronger than a 2, and so on. It just increases by 10 each time, because you have 1, 1.1, 1.2, 1.3, and you're just continuing to increase the strength of those earthquakes. So fairly minor stuff going on here. Up here, depending on the way the building was built, how well it was built, you may have furniture, moves, chunks of plaster possibly coming off the wall. Brand new house probably wouldn't be affected. I know 1986, there was an earthquake that occurred while the World Series was going on in San Francisco. I think that was an 8.6, if I remember correctly. Did a lot of damage. The Bay Bridge, where traffic goes over the top and underneath, some of those sections collapsed, and if they didn't collapse, there was one that shows video where you can see this car traveling and all of a sudden it goes down and the car doesn't have time to get stopped and it goes over the edge. So I usually talk about this experience, and the kids weren't even born now when I tell the story, but back in 1988 we lived up around the corner from the post office, and I was laying on the couch one night watching the movie Ghostbusters, and I remember hearing this creaking sound. It was kind of over in the corner of the room, and then it just kind of traveled across the ceiling, and then it was gone. And I'm like, wow, that was kind of weird. Wonder what that was. Anyway, come to find out it was a minor little earthquake. Another time we were up camping. We were out on a ride in a truck, so we didn't feel anything, but my wife was in the tent. She was having a nap, and when we got back, she said something about feeling movement, and I said, well, I don't know, I wonder what it was. And I said, well, there's those big pine trees that are right by the tent. I wonder if the wind was blowing and maybe a root had pushed up, but come to find out it was like a 4.5 earthquake that had happened over the mountain into Sevier County or something. Okay, tsunami, a giant wave in the ocean caused by an earthquake. The word tsunami is a Japanese word, and if you go online and look up tsunami, especially Japanese tsunami 2011, there's some pretty amazing footage from that tsunami that you can see. There's one I always show the class. It's about 15 minutes long, and you can see in the video at the start, you can see the waves. You can see it's not a huge crashing wave, just the elevated water. You can see it coming in. You can see it moving. And there's a guy, of course, speaking Japanese, and he's screaming and getting upset because he knows that this tsunami is coming. Then as you watch it, they have this probably 10 or 12 foot seawall, and eventually the water goes over it, and it moves cars, it moves small buildings. There's boats that come detached from their moorings, and just amazing amount of destruction. There was a large piece of something, I don't know, that became detached from a harbor, and it actually made its way across the Pacific to the United States during that tsunami that had taken place. So And then towards the end of the video, you can also see that it's now stopped coming in, it's starting to settle, and then you can actually see it start to move back out. So pretty amazing footage if you have a chance to look at that. And that's our third page. Thank you.